Hello, everybody. On today's Engineering 101 podcast, we have a very interesting topic that I am sure everybody is interested to know, and a lot of people has wondered about before. So when I was watering my plants the other day, I put my finger on the hose thinking that it's gonna block it, but instead it was going faster and further. And in my brain, that didn't really make sense. Yeah. So, but I am sure that there's an explanation for it, a scientific explanation for it. So I came to the expert to tell me why. Why does the water go further when you block it instead of stopping it?
Yeah. There is an explanation for it. That's the basic principle of fluid dynamics, Bernoulli's law.
Okay.
And Bernoulli found out if you narrow the diameter of a current of liquid, you have to speed up the liquid, and that's what you experienced.
Okay. So when I block it, it goes further because I narrow down the space that it goes from?
Correct.
Sure, you can explain it to us more using the experiment.
Here, HM250.07, that symbolizes your water hose. Restrictor built into the flow, into the flow line. This restrictor narrows the diameter of the flow line and shows you the effects of that onto the current, on the fluid dynamics.
Okay.
What we see here is when the water goes into the restriction, the speed immediately increases and the pressure drops a little bit.
Okay.
So we increase the speed on the expense of pressure. And when we go further, when we go to the extensor, the speed drops again slowly and the pressure recovers.
I was going to ask you, what does that have to do with my water hose though? Is it the same concept?
It's the same concept. Your extension is much wider if you let the jet move to your plants. But because it is what you get. You get an extension of the reach of your water.
Okay, because if I make it smaller, then it expands because it has a smaller place to go from.
Yeah.
Oh, okay. That's actually very nice. I was wondering if there's another way for people to understand this concept in case they don't have access to our device.
Have access to the experiment. We have a very nice graphic demonstration on our website.
An e-learning course that people can access, and it's completely free of charge, right?
Yeah.
Okay, so this one kind of is a stimulation of what we were explaining in the experiment earlier.
What's happening there in a graphic explanation. So the visualization shows us the incoming flow and how the molecules behave when they meet the restriction. You see them, they squeeze in and then they have to speed up to move through.
Yeah.
And that's what we see here.
So we see that this...
So we increase the speed from 1.4 to 6.3 meters.
But the pressure also goes down then, okay.
Is...
less here than...
Yeah. Now it's recovering.
Okay.
But in the restriction, the pressure is less.
Yeah. So because we are kind of blocking it from going, it goes faster.
Yeah.
Because the space for it to move is a smaller space.
Yeah.
Okay. Okay, that's very nice. Faster the speed, the lower the pressure?
Exactly.
Okay. That's very nice. And I think this course, or it's a full course actually, that they can access for free of charge on our website. And I think this is very interesting because you can actually try and move everything and play with it by yourself and have a different, see if I pressure it from here instead. Now we have, this is close to this and this is the same because the smaller here it is, but the pressure is more.
Yeah.
Okay, that's very nice actually. Okay. That's a very good explanation. Thank you so much.
My pleasure.